Okay, example 1, right? We want to solve the system, and I will start with this system. So we have 3x plus 2y equals 48, and we have 9x minus 8y equals negative 24. Okay, so this is our system, right? Again, here's equation 1, here's equation 2. And notice that these both equations are already in standard form, right? Ax plus by equals your constant c. So we don't have to rearrange it. It's, the setup is nice. So step 1, I guess you can say, is check, because the equations are in the standard form. Now, the goal is we want to add these equations, okay? The equation 1 plus equation 2. And when we add them, we want one of the variables to be eliminated. So for example, if I add them as they are right now, I would get 12x, right? 3x plus 12x. 2y minus 8y is negative 6y, right? And then 48 minus 24 is 24. Now, there's nothing wrong with this. I mean, we added the equations, but I still have an x and I still have a y. We want to eliminate one of them, hence the name elimination method or addition method, because we're adding these two equations vertically. But again, we haven't eliminated any variables, so this is not helping. We want either these guys, right, or the x's or the y's to cancel. So what I'm going to do is I'm going to multiply, let's see, well, let me maybe write this down. So I want to eliminate, let's just say my x variable. Well, again, I get 12x when I add 3x plus 9x. So what I'm going to do is I'm going to multiply the not the second equation, just kidding, the first equation by some non-zero constant, right? That's a non-zero constant. 3 is not 0. And I'm actually going to multiply it by negative 3. And when I do that, or why did I do that? Well, this is just, I'm just going to write this down again. So, and I believe that was I think that was a plus sign. Plus 2y equals 48 times negative 3. Okay, so why am I multiplying by negative 3? That's a negative. Well, when I distribute, right, I get 9x plus 6y, right, and 48 times negative 3 is negative 144, 4, yes, 144, or negative 144. And now I'm going to rewrite my system, and let me just shrink this a little bit. Okay, so what's my system? This is still equation 1, okay? I just multiplied by negative 3, and I obtained 9x plus 6y equals negative 144. And then I'm going to copy my second equation that I haven't done anything with, and I am forgetting a negative right there, right? Because I multiplied negative 3 times 3x is 9x. Okay, so I want to add these equations, right, vertically. And again, no change. This is equation 1. This is equation 2. And when I do that, negative 9x plus 9x, right, this guy, that's a big 0, right? 0x, which is 0. So I've eliminated my variable, hence, again, the name elimination. Or I'm using the addition method because I'm adding the equations vertically. 6y minus 8y is negative 2y, and again, oh, too many mistakes. A negative times a positive is a negative. Oops, I don't want that. I'm just trying to erase this, but this guy should be a negative. So that should be negative 14. Oh, sorry about that. I'm working on 2 hours of sleep. Okay, there's my eraser. Okay, let's just erase that or cross that out. So I get negative 14y, and if I add these guys, I get negative 168. And I want to solve for y, so I'm going to divide by negative 14, right, by the coefficient. And this is just 1y, and 168 divided by 14 is positive 12. So I found my y value. So there's a unique solution here. Remember, we're trying to find the point of intersection. Right now, my y value is 12. So now all we need to find is the x value. So up to this point, right, the substitution is very similar, right? We're just not substituting an expression back into another one. But we can find our x value now. And you can substitute it into any equation you want. So I will use, just pick an equation. I'll use the first one. So 3x, and this is actually back substitution, right? Back substitute. 3x plus 2y equals 48. Okay, so 3x plus 2, and then what's y? Well, it's 12, right? I just found y. It's right there. Equals 48. And again, just solve this linear equation. All right, this is 24. If I subtract both sides by 24, I get 24, right? Minus 24, minus 24. 3 times what is 24? Well, it's 8. So x is 8. Thus, the unique, right? There's only one. The unique solution is 8, 12. Okay, so this is case 1, right? If you graph these lines, right, which this is not how they look. I'm just kind of generalizing here, right? The point of intersection is going to be at 8, 12. Okay, quick check here. So check your solutions. So we have, okay, 3x plus 2y equals 48. When you check your solutions, make sure you check the original equations, not the equation that you multiplied, negative 3 by. Okay, so let's see, what do we have? 8 and 12. Okay, so 3 times 8 plus 2 times 12. Does that give me 48? And yep, 24 plus 24 is 48. So check, that works. 9 times 8. 8 times 12. Does that give me negative 24? And we do the 17, 12, 24, 36, 48, 60, 72, 84, 96. Is that, does that give us 24? And 72, 82, yep, that does give us negative 24. So 8, 12 satisfies, okay, both original equations, right? Thus, it must be the solution. So again, this is the addition method. We're adding vertically, or the elimination method because we're eliminating a variable. Okay, so look for example 2 soon. I'm going to do it right now.